This video is going to be a review on statics for the calculation of a moment. Now, moment is very simple. Moment is just force times a perpendicular distance. That is pretty much it in a nutshell. Now, let's draw a nice pretty picture. So assume that we have a beam, we have a force that's acting down on this beam, and we want to find the moment about A. Well, all you need to know is the perpendicular distance from the force to A. So the moment about A that this force is going to cause is just simply force times distance. Yep, that's it. But don't forget that every single time that you're going to calculate a value, you need to state not only the numerical value, the units, but also the direction. So what direction does this create? Well, technically, let's just imagine it's going down, down, down. We are rotating about A, so it's going to be going in a circular fashion, and that circular fashion in this case is going to be going counterclockwise. So don't forget to also include your direction. Now, what we're going to be doing for this video is an example problem in 3D, because yes, if you can do it in 3D, you can definitely do it in 2D. 2D is much simpler, so why waste the time going over the baby stuff? So here in this video, we have a set of 3D axes in our X, Y, and Z directions. And we have like a semi-pipe shape looking thing. It's not a pipe because it's not circular really, but it is kind of like a tube-ish shape, square tube. We have our point O at the origin of our coordinates over here, and we're going to take some moments about that point. We have it going 3 meters out in the X, 2 meters then out in the Y, and then down 1 meter in the Z. That's the kind of shape I've tried to draw. And at the end of this little square pipe network, we've got forces in the X, Y, and Z directions. And what we're going to discover is how these forces in the X, Y, and Z direction actually create moments about our X, Y, and Z axes. And the big thing to take away is which forces can do what. So the force in the X direction can only create moments in the Y and Z directions. It cannot create a moment in the X because the force is going in the X. So that's parallel, not perpendicular. Now, just because it could create a moment in those directions does not necessarily mean that it always does. But these are the two directions that it could potentially create a moment about. For Y, it is the X and Z directions. And for the Z force, it's the Y and X directions, or the X and Y, however you want to say it. If you haven't noticed, it's obviously the other two directions. That's not the one that the force is in, right? So these are possible directions that they could create the moment. And it all depends on where these forces are actually in your picture. So let's start off by talking about what moments force X creates. So to do it again, it could be both Y and Z. So let's start off talking about, does it create a moment about the origin? Let's do the Y direction first. So we're going to do it about the Y direction. So again, it is force times perpendicular distance. So it is going to be force times which distance? That's the really good question. So what we can do is we can kind of pretend that force X actually acts way over here. Yes, we are still going to be the 1 meter down from the y-axis, but technically we can have this force anywhere along our axis. You can just scoot him up and down his axis. So he is in the x-axis direction, so you can just scoot him up and down in the direction until he's pretty much right around, under, over, left, right, really kind of depends on which one you're talking about, to where he's directly next to his axis that you want to take the moment about. So in this case, it's really easy to see that this force, if we just kind of imagine him kind of twisting around, he's going to go under the y-axis and come out and over the top of it, because he is going to rotate 1 meter away from the y-axis. If he was in line with the axis, if our force is in line with the y-axis, he cannot create a moment about the axis. Because technically what's happening, he doesn't cause any rotation. Instead, he literally just causes this guy to just up and move, right? He only causes translation. He won't actually cause rotation if he's pointing directly at the axis. So that's why, whereas he could create a moment, he doesn't always create a moment. So again, the moment in the y direction about point O, about that axis, is going to be force x, in this case, times 1 meter. I did pick them all to be different sizes just so that you can kind of see where they're coming from and you don't get confused as to which one was which. So let's do the same thing for the moment in the z direction, still again with force x. So force x, again, we can scoot him wherever we want to go. In this case, we want to see how he causes twisting about this z-axis. So in this case, what we can do is we can just kind of bring him up. Sounds kind of silly, but we can bring him up some. And all we need to do is just see if he is, say, up here. You can scooch him forward, just kind of bring him up. How does he cause twisting this direction about the z-axis? How does he cause it to twist? Now, it's pretty hard to draw in 3D on this 2D plane. It's very difficult. So instead, what I want you to do is I want you to use your arms and really kind of feel this one out. Put your one arm in the direction of the z-axis. So just lay your arm down in the direction of the z-axis. It's not really down, I guess it's up. So take your arm and put it in the direction of the z-axis. Now with your other arm, take your hand and point your fingers in the direction that the force is going. So our force is going to be going outward here. So we're going out, and then just kind of move your hand in the direction that your fingers are going and kind of arc it back toward your arm that represents the axis. And you're going to see the direction that this force creates a moment. So again, how is it going to create that? We want to know what's the distance that this force is from the axis. So again, I'm going to just kind of scoot this force up just a little bit more and say he's right here, right? I'm still scooting him along his x-axis, and what I want to know is the distance that I am to the z. So you can see that that distance is my 2 meters. So this is force x times 2 meters is going to create the moment in the z direction. Now, that one might seem a little bit easy because it's force in the x direction, but again, the same concepts are going to apply as we go into the other directions. So let's do the same thing over here. Let's talk about force y. Force y, again, is going to create a moment about the x-axis and a moment about the z-axis. Well, let's talk the x one first. So let's just kind of clean up our mess that we've made over here just a wee bit. And let's talk force y. We want to know, does he create a moment about the x-axis? So again, we can scoot him anywhere along his little axial direction. So we're just going to pick him up and move him over here. And again, I want to know how far away he is from the x-axis. So how far away is he from this x-axis? That's going to be our z-direction height over here. So that's just going to be 1 meter. So again, that's going to be force y times 1 meter, right? So you just pick them up, kind of scooch them along. Now let's look about the moment in the z direction. So again, we can scooch him over. But again, all we care about, we don't actually care about where he really is. We just want to know he's along this line like we drew, right? There he is. He's scooched over, so he's a little bit clearer to see. But we can actually even scoot him up now. He can actually go up in the z direction, and we can place him along that axis because all we really want to know is how far we are from the z. Because again, he's going to cause rotation this way around z. So that distance is 3 meters. It's really kind of difficult to see this on the 2D plane, but I hope it's kind of working for you guys. Now let's look about the z direction force and what he does. So we're going to attempt to clean up this hot mess that we just made, at least for the most part anyway. So let's talk the moments it creates. We're actually going to do the moment in the x direction first because, you know, that just makes more sense in our alphabet. And then we'll do the moment in the y. So again, both of these are just going to be the force z, but then times what distance? That's the important question. So we're looking at force z. So just as a reminder here, force z, this is force z. And I want to know how it's going to create a moment about x and y. And I think honestly that this is probably the easiest one to consider because you can lay your arms down in the x and y plane because that's the flat plane that's on the desk. And then you can point your hand up for force z. So effectively what we're going to do is we're going to move him up along his axial direction, and we're just going to put him right here. We're going to say this is force z. So does force z cause rotation about x? The answer is obviously yes. So force z, again, you have probably your left arm laying down in the x direction. You've got your force z over here with the right arm, fingers pointing up because that's the direction of the arrow. And as you arc it over and around, you're going to see, yes, it's going to create a moment. And that moment, again, the force times the distance that your right arm for your force is from your left arm, and that distance is 2 meters. So that's cool. Next, we're going to do the same thing, but we're going to do it for the y. So we'll just change the color over here. And now we're going to do the same thing. So we're going to put our right arm down. We're going to put our left hand up as our force. And we're going to see, does it arc over the y-axis? The answer is yes. How far are we? We're going to be this far as we arc up and over and down and around the y-axis. So that distance is 3 meters. So again, you may notice that I did 1, 2, and 3, but what we can also do is come back in here and our 1 meter that we have, this guy right here, he's actually a z distance. And our 2 meter is actually a y distance, and our 3 meter is actually an x distance. So what you could really do is you could come back over here and you could replace each one of these by their respective letters, and you're going to kind of notice a trend, right? So if we're just looking at moment in the y caused by force in the x, you notice it's times a z distance. I really wouldn't think too much about it though, and that way maybe it helps you to think of it that way. You're going to see the same trend over and over again with every single one of these. But if that's what works for you, that's great. But personally, I'm a big kind of visual person. I like to just use my arms, my hands, and everything and just kind of see how it really arcs, because this is going to help you with the direction. Because again, it's not just about the number. It's not just about the number in the units. It's also about the directions. And the directions are easiest to see when you are actually physically kind of doing the motion with your hands and your arms. But I hope that's helped clear up some things for moment calculations, and that's the end of this video.